Okay, this lecture is over Chapter 2 of your textbook, which is titled Input, Processing, and Output. The first probably two-thirds of this chapter deals with Python concepts and Python statements and syntax, that type of thing. And the last third of the chapter concentrates on something called turtle graphics. So probably what I'm going to do is cover in this lecture up to the point that we get to turtle graphics, and then I will do a second recording on the part of the chapter that deals with turtle graphics. So I'll split it up like that. As far as topics in this chapter in more detail, we're going to be talking about programming, input, output, processing. We'll start talking about some Python functions such as print and input. We'll talk about comments in your code. We'll talk about variables in Python. We'll talk about how to read input from the keyboard, how to perform calculations, talk about strings and manipulating strings, in particular concatenation, which is sticking two or more strings together. Go a little more in depth into the print function. We'll talk about formatting output, and then we'll talk about named constants. And then, like I said, the last third or so of the chapter is on turtle graphics. That will probably be in a different lecture. So programs must be designed before they're written. That means you need to think about it, come up with the algorithm, which is the steps or process to solve the programming problem. And we have something called the program development cycle, which is you conceive the program and think about how you're going to solve the problem at hand. Then you write the code. In this class, of course, that code would be in Python. You would then try to run it. First thing you might have to deal with is syntax errors, which means you've gotten the statement incorrect. Maybe you forgot a quote, maybe you forgot a comma, that type of thing. And Python's going to complain about that and give you a syntax error. So you would then need to correct any of those syntax errors, try to run the program again. Once you eliminate all the syntax errors, you're going to test the program by giving it, for example, different sets of inputs. If it's performing a calculation, different input values, so that you get different, hopefully correct output numeric values. If you input data and your program runs and doesn't give you the correct answer, or doesn't give you the behavior you expect, then that is called a logic error. And then you would need to go back and look at your algorithm or your code and try to determine, did you do your algorithm wrong, or is the algorithm right but you didn't implement it correctly in Python. Once you correct logic errors, then you would go back, test the program until you're confident that it is working correctly. Okay, if you're designing a program, of course in this class you're going to be programming to get credit for programming assignments, that type of thing. But out in the real world, you will have customers, and basically a customer will come to you, tell you what they want the program to do, and then together with the customer you would develop a set of specifications. Once you think you have the specifications of what the user wants and they've verified that you are understanding correctly, then you would start writing the code. One thing they talk about here when developing the algorithm or writing a program, it's better to break it down into a series of smaller tasks instead of thinking about the whole program as a whole. That allows you to focus more on a subset of the problem, and you will more likely get a correct answer and get a correct answer more quickly if you do that. I've already defined algorithm, but here's their official definition. It is a set of well-defined logical steps that must be taken to repeat a task. And you can have logic errors or problems with the algorithm. For example, one that's been used for years is the instruction on a shampoo bottle. It basically says put some shampoo on your hair, rub it in to wash your hair, rinse your hair out, and repeat. So their intention is you would go through that process a second time. But technically, if you're following that algorithm, you would never stop washing your hair, because when you get to the bottom, they've basically created an infinite loop by saying repeat. That's an example of a very simple algorithm, and a very simple algorithm that has a problem with it in that there is no end to, in this case, shampooing your hair. Pseudocode, different people have different opinions on this. It is supposed to be English-like, so you would write down things like, you wouldn't worry about Perl, but you would say, give this question to the user, then read a value from them. Now that you have that value, perform this calculation. If the value of the calculation is this range, do this, otherwise do that, and then give the answer to the user and terminate the program. So if you wrote that kind of in, quote, English, that would be considered pseudocode. Now, some people, when they write pseudocode, just say, write it like English. Other people, they have keywords that they expect you to use. But either way, pseudocode is kind of the first step at coming up with an algorithm that's going to lend itself to coding in whatever language you're going to be coding in. So for this class, Python. It allows you to, like I said, think about the problem. You don't have to worry about syntax errors. You're just concentrating on solving the problem. Once you have the pseudocode and you think it's detailed enough and correct, then you can start the process of translating that into, or writing that into, whatever programming language you are using. I used to teach Fortran back, I guess, in the 1980s at the University of Kentucky, and there are a couple of things in here that are mentioned that used to be a bigger deal back then, like flow charting. Students had to create a flow chart for every program they did. So basically, it's a graphical depiction of how your code is going to execute and how you would move through your code. So it might look something like this. So things in oval boxes are called terminators. So it may be the start or end of your program. Anything in a parallelogram that is not a rectangle is an input or an output statement, and things that are in rectangles are statements about what you're doing. In this example, they're going to take two values the user inputted and perform a calculation. So these flowcharts, this is what I would call a straight line program. It just starts at the top, runs down the page until you finally hit the end statement and your program terminates. They're just saying here, I think they talked about this in chapter 1, and hopefully you know this from CIT 120. Typically you get some input, you perform calculations, and then you produce output. Now, it's not always that simple. You might read some values, you might perform some calculations. Based on those calculations, you may read some more input, you may produce some output, read more input, produce output. So there are programming languages from like the 60s and 70s where you did have to do all of your input first. You had an input section, then you had a calculation or a processing section where you would perform all of your calculations, and then at the end you would have an output section that would do all of your output. But these days these can be intertwined however you need for your program to work correctly and look nicely, or look nice and have a nice interface with the user running your program. In Python, you have a print function. Now might be a good time to mention this. Python 2 was very popular for a long period of time, and Python 3 was created, and Python 2 and 3 kind of coexisted together for a while, and to some extent still do. So there were some things, for example, the print statement in Python 1 and 2, you did not have to have the parentheses around the argument list. In Python 3, it is required. All functions have to have parentheses. So for this class, if I did not state this in the History of Python lecture, we are going to be using Python 3. So the correct syntax, the way we use the print function, is you have the word print, and within parentheses you have one or more arguments that are going to be printed out. In this case, things in single quotes and double quotes, they'll tell you this a little later, are string literals. So literally print out hello world, exactly as shown here. So with a capital H and everything else lowercase. So what they're showing you in this graphic is you have the Python prompt, which is the three greater thans, and you type in, I want to print hello world. Python interprets that and then prints out hello world, and then gives you the prompt back, which is basically saying, okay, I did what you asked, what would you like me to do next? So this is a super simple Python program that just prints out a string literal hello world. So a function is a piece of pre-written code that you can call and have it do something for you. So if you're trying to break your problem into smaller pieces, or you have some action that you're going to be doing over and over again, you might choose to put that in a function. So instead of writing a chunk of code over and over and over again, you put it in one place in the function and then call that function. So that allows you to reuse it. And better yet, let's say your program is going to call this function 100 times, and down the road you determine that you need to change the function, or maybe you had a logic error in the function. Instead of finding the 100 places that it occurs and fixing it 100 times, all you have to do is go in and fix the function. So you only have one place to find, one place to correct your problem. So those are a couple of reasons why functions are a good thing and why you might want to use it. I used this term a moment ago. We have arguments that we pass into functions. So these are variables or strings or constants. So for example, on the previous screen, it had one argument, which is the string literal hello world. The statements within a function are just like statements in the main program. That is, they execute from top or bottom. I have a little bit of issue with what they say here because it's not always that simple. You might do some repetition, you might do some branching, which causes you not to go top to bottom like they're mentioning here. But you do start at the top of the function and execute till you hit the end of the function, or until you hit a statement that's going to return execution to whatever part of the program called the function. So here is 3 print statements in a row, and this is what they mean from top to bottom, and what I'm calling a straight line program. It prints programming, it prints the word is, and then prints fun with an exclamation point. So the top 3 line, or the 3 lines in the middle, are 3 print statements of Python code, and then when you run that, in the blue box is the output that this Python code is going to generate. A string is 1 or more characters, and a string literal is basically comes from literally I want you to print hello world. They may be closed in single quotes or double quotes, like we saw in the previous example. One of the cool things about Python is they have something called triple quotes. Really, probably what you're going to use is 3 double quotes, what's shown after the ors. But what happens is you can have a string literal that spans multiple lines. So you put 3 double quotes, write your multi-line string, and then put 3 double quotes to end it. This allows you to kind of write a block of code and easily format and line things up. So that's one of the handy things I think that Python has that I like. Comments, as you should know, are comments or statements that the programmer wants to make. So when they go back and look at the code, or when somebody else is looking at the code, they can remember what the code is doing, or tell somebody else what the code is doing. So in a lot of programming languages, and also true in Python, if you encounter a pound sign or hash mark, whichever you're used to calling that symbol, and it's not part of a string literal, everything from that pound sign to the end of the line is ignored. It's like it is not there at all, so it does not try to get interpreted and executed by the Python interpreter. You can comment out a whole line by the first character on that line being a pound sign, or you can write some Python code and after that code put a pound sign and put a comment documenting that line of code. So either way works. The other thing we have is variables. If in 120 you had to use variables, in any programming language you've programmed in, you had to use variables. And basically it is a reference to a location in memory that is going to store data for you. The way a variable gets a value most commonly is the assignment statement. The general format is shown here. You have the name of a variable, you have an equal sign, and then you have an expression. And I used to teach Perl, which is very similar to Python, for years. And I told students that they should kind of think about, or get used to thinking of, the equal signs as get set to. So in this example, age equals 29, or age gets set to 29. The equal sign used in this context is referred to as an assignment operator. Here are some examples. In the first one, the variable temperature gets set to the integer 75. In the second line, the variable cost gets set to 87.99, which is a floating point number. And then the last one is a variable named name that gets set to the string literal Monty. So those are some example assignment statements with different types of data in Python. For this to be syntactically correct and work, the variable has to be on the left-hand side of the assignment statement, or as we'll see in a moment, variables. A variable can be passed into a function. For example, the print statement before had the string literal hello world. We could have just as easily said print x, and whatever value is being stored in the variable x would be printed to the user. For a variable to exist and be used, it first has to be assigned a value. Here's an example where you can do multiple values. You can have multiple variables or a list of variables on the left-hand side of the assignment statement, and then you have a matching number of values on the right. So in this case, this would be exactly the same as executing the code shown here in the middle. X equals 0, y equals 1, z equals 2. This is referred to as a multiple assignment. And the separator between the variables on the left-hand side and the values on the right-hand side, the separator is a comma. You have rules for what are valid or not valid variable names. So you cannot use keywords. I think I mentioned that in chapter 1. So you cannot, for example, name a variable print because Python wouldn't know what to do with that, because print is a built-in function. The first character of your variable has to be a letter or an underscore. Nothing else is acceptable. After that first character, you can use letters, numbers, or underscores, as many as you'd like, to come up with that. And variable names are case sensitive. So if I have a variable ABC lowercase and another variable that's capital A, lowercase b, lowercase c, even though those are the letters ABC, those are not the same variable because the capitalization or the case is not exactly the same. You can print multiple things. I think I've already said that the argument list can have one or more arguments. So you pass those into a function, for example, print, and items that when you pass them into print, they will automatically be separated by a space when they're outputted to the screen. Variables can change values while they're executing. Python and some other languages have something called garbage collection. It is possible to have a variable. A variable in Python is really a reference to a memory location. So if X referenced a memory location that had 10 in it, and then you changed it so X now represents the string XYZ, that variable points to that string, and that value it had before is just kind of out there in memory with nothing referencing it or pointing to it. So Python garbage collection is going to realize that nothing is representing that chunk of memory, and it's going to free that memory up so that you don't have a memory leak, which is a bad thing. A variable can refer to any data type. So I can set X to 10, I can then turn around and set X to Wayne, then I can turn around and set X to 3.14, and those are all different data types, the integer, a string, a floating point. But you can assign a variable any type you want, and what they're getting at here is you can actually change that data type as the program executes, if it makes sense to do that. Data types refer to the type of data you're representing. So we have integers, which are represented or converted to using int. For real numbers that have decimal points, that is a floating data type. A string or str is used for strings that are stored in memory. A numeric literal is when you actually put a number, like if you say x equals y times 3, that 3 is a numerical literal that represents an integer because it didn't have a period. If there was a decimal point, then it would be a floating point literal. So if you said something like some value equals 2 times r times 3.14, that 3.14 is a floating point literal. We do have some operations that we use the same operation symbol, but they may behave differently based upon what type of data you pass into it. So here's kind of an example, kind of like what I was talking about a moment ago. We set x to 99. We then turn around and set x to a string that says take me to your leader. That 99 is just kind of lost out there in memory, and the Python garbage collection is going to come back and eliminate, free up that memory location that is storing that integer 99. Almost all programs are going to get some type of input. It may be from a file, which we'll talk about down the road, or it may be from the user, which is what we're talking about here. The way we get input from the user through the keyboard is using input. So the example is I want to give a prompt, which is usually asking the user to input a specific type of data, or another way to say that, tell the user what we want them to input. We then read that and then store it into whatever's on the left hand side of the assignment statement. In this case, it's a variable, named variable. And all input is a string. I think we'll get to that in a moment. And the other thing to know is if you want a space after the question, like if you want to say what is the value of x question mark, typically you're going to want to put a space after that question mark just so it looks nice when the user runs the program. That space is not put there automatically by the input. If you want a space in your prompt, then you need to put a space in it. So here is an example, what is your name, with a space after it. The user will type in their name. That will get read and stored in the variable name. Like I said a couple of slides ago, input is always read as a string. If you want that input to be a number, you have to convert it to the number yourself. Now sometimes people have trouble really understanding this, but basically if you type 34 instead of that being 34, what Python's going to read is the character 3 followed by the character 4, and there is a huge difference. Now if you wanted that to be the number 34, then you would use the int function to convert the string 34 into the numerical value, the integer 34. The other thing they just kind of throw out here is that you can nest functions, and a lot of times when you are, that's referred to as casting, when you're casting one data type from input to another data type, it is real common to use function nesting, something like this. So the innermost function, which is input, would execute first. It would say enter a number, :space. The user would then type in a number. That value would be returned in place of the input function. And then that int would say I want that string, whatever the user typed in, to be converted to an integer value. And then I would like that integer stored in a variable number. Here's an example using floating point number. So no matter what the person puts in, if they put in 34.5, if they put in 35, it's going to convert it to a floating point number, and then it's going to store that numeric value in the variable score. There are different types of operations that can occur. They're going to start out talking about mathematical operations, but you can also have logical operators, which are like and, or, not. I hope you've seen that in 120, but we'll probably talk about logical operators at some point. A math operator is something that performs a mathematical calculation. The operands are the values or variables that the mathematical operator is going to operate on. It performs a calculation, and then it assigns that to a variable or prints it out. The first thing they talk about here is division. When you have a division, just a single slash, that is going to perform a floating point division, which means your answer may be a floating point number, like 5 divided by 2 is 2.5. If you put two slashes together, it's going to perform integer division, which is what I call second or third grade math. You know, in second or third grade, if you were asked what is 5 divided by 2, if I ask my students that, they'll say 2.5. And I say, well, you didn't know about decimal numbers in second grade. And then they would say, okay, it's 2.5. And it's like, well, you don't know about fractions until third or fourth grade. So the way you would say this in second grade is, you know, your teacher would say, you have 5 apples. How many sets of 2 can you take? 2. How many do you have left over? 1. So the integer division is the integer part of an integer division. So in this case, if we did 5//2, the answer to that integer division would be 2. Here's some mathematical operations that, you know, the first ones you should definitely be familiar with. It's addition, subtraction, multiplication, division. We just talked about integer division. Kind of a counterpart of integer division is what they call remainder. That's usually referred to as the modulus operator or the mod operator, and it's going to return the remainder. So I said 5//2 is 2 because that's the whole part of the division. 5% 2 would be 1. So, you know, you have 2 remainder 1. So the mod operator would return the remainder of an integer division. And then another one you should have seen is 2 asterisks together, which means exponentiation, which is to take the number on the left hand side of the operator and move it to whatever power is on the right hand side of the operator. Division gives you a floating point number. // since it's an integer division, will give you an integer result. When you program, you have to worry about something called operator precedence. And if you don't like the operator precedence, which is the order operations occur in, then you're going to have to enclose things in parentheses. Exponentiation will happen after things grouped in parentheses, followed by multiplication, division, and mod, and then the last thing that will occur will be addition and subtraction. And the order of precedence, if you have three plus signs, or even if you have a plus sign, a minus sign, and a plus sign, since they're equal level of precedence, they will be evaluated left to right. So the very first plus sign you see would be executed, then the minus sign, then the plus sign, in the order they appear, left to right. Exponentiation, I already told you, is to raise something to the power, and then I gave you a couple examples. They even happen to use the same example I did, which is 5 mod 2. The other example they give, 4 mod 2, well, 4 divided by 2 is 2 with a remainder of 0. So the mod operator would return a 0. What you're going to do is you're going to go through and use those operators that were shown to write your mathematical expression. Again, if the order of precedence is not going to work the way you think it should, you're going to need to put parentheses to force it to be evaluated in the order you want. This is just talking about float and int and what they do. And they're also pointing out that if you have a floating point number and use the int operator on it, then the fractional part or things after the decimal point disappear. Sometimes you have great big long statements and you want your code to look nice on the screen or possibly printed. If you have a really long, for example, math expression they're showing here, you can type as much as you want on a line, and then if you put the backslash character, that means this statement is going to be continued on the next line. So here's another example. You're trying to put out information. They're saying that anything that's within parentheses can be broken across the line without using that backslash continuation character. So putting parentheses around something would possibly make that a little easier to write and to look a little better. Here's the first example where they talk about symbols possibly doing different things depending on what the values are. So when you have something like 2 plus 3, it's going to perform addition. But adding the word hello to the word world does not make any sense. So what it does when you put a plus sign is it says stick them together or concatenate them together. So in this case, the message, as you see as a result of the print statement, is hello and a space, immediately followed by the word world. This is showing you how to break up a literal by doing concatenation without using the continuation symbol on the end of each line, because you put things in parentheses, and this would output enter the amount of sales for each day and press enter. So it would output that as one line, one string literal. You can just stick strings together without that plus sign, and that implies concatenation. Again, notice no space is automatically put in the output for you, so it just print 1, 2, 3 all crammed together. Here's another example of using a string literal across several lines. In this case, they did put the spaces after the first two strings so that the output isn't crammed together and looks nice, sorry. When you use the print function, it always prints what is a new line character, and that's comes from the programming language C and is used in Python and Perl and lots of programming languages. But a new line character basically means you end the current line and go to the beginning of the next line. You can put a delimiter. If you specify a delimiter, then instead of a new line appearing after every chunk of output, whatever the delimiter is will appear. And the way you do that is using a separator, or SEP equals whatever delimiter you would like to use. So the other thing that we might need to do is do special characters like a tab, or actually specify one or more new lines. And we can do that using a string literals that start with a backslash. So \n is the new line character. \t means put a tab in there. So there are a whole bunch of characters that you can use by putting a backslash in front of some other character to signify, like they're doing here, a new line or a horizontal tab. These are processed by Python, and then whatever you specified is placed at that location in the output. Here you can go and do some formatting. You have strings that are considered special literals that start with an F, and what happens is they are going to be interpolated. That is, for example, you set a variable to Johnny down at the bottom, and then you print hello, and then in curly brackets you have a variable name, and what it's going to do is it's going to look up the value that's in that variable and put it in the string. So executing the assignment statement and the print at the bottom of this slide is actually going to say hello Johnny, or whatever value is currently in the variable name. Here we're performing mathematical calculations. In the first one on two integer literals. In the second, we're looking up the value that's in the variable val, which happens to be 10 from the assignment statement before, adding 2 to that, getting 12, and then it would actually output the value is 12. Here we can go through and do some formatting. So what happens here in the curly brackets in the print statement, kind of in the middle of the screen, it says I want you to look up the value num, and then I want you to format it as a floating point number, which is the F, and I want 2 places behind the decimal. This is a common way to format things. It ultimately came from the C programming language, and it is a very handy way. Where that 0.2f is, if I put 5.2f, then there would be a couple of spaces in front of the 123.46. If in other languages, if you do like 5.2, then instead of 2 spaces in front of the 123, it would put leading zeros because the format specifier had leading zeros on it. So that's a very handy way to make your output look, quote, pretty. Here's some other examples. Print the number, make sure there's 2 places behind the decimal point. I want it as a decimal point with no places behind the decimal point, or I'm sorry, I want it as a percentage. So it would print 50%. Here's taking a number and printing it as a decimal number. The second example is using scientific notation to output a value. Here is putting a field width that specifies the total output area that you have and that you want 2 places behind the decimal point. So that's kind of like the example I talked about before. You can use left alignment, which you might use for strings. You might want right alignment because you're doing dollar amount calculations, or you might want to center things, which you can use the caret for, which is a shifted 6. So these examples are left justifying, right justifying, and then centering output in 20 characters. So this is just showing you the different parts that you can have. You can have the alignment, you then can have the width, you can then have a precision, and then you can have a data type that you're going to use. I don't know that I really like this, but they are referring to something called a magic number, which is just some numeric literal that appears. So here we're taking a balance, we're multiplying it by 0.069, and then putting the result in there. Well, there is no comment or explanation of why we're multiplying this by 0.069. So what you can do is you can go through and they're talking about problems. What if you do a typo? Well, the way you solve some of these problems that you might have with magic numbers is something called named constants. So I have something called interest rate, and it is set to 0.069, oftentimes done in all capitals. So now what we do is we say the amount that we get is our balance times the interest rate. Well, that makes a lot more sense to somebody that is reading the program. It's also easier to maintain if your interest rate changes, just like I was talking about with functions. You only really have one place that you need to change that. So that gets us up through all of Chapter 2 with the exception of Turtle Graphics, and there will be a Part 2 video that talks about Turtle Graphics.